In 2026, a Chinese high-speed train races through the Saudi desert. Outside the window, temperatures soar above 50 degrees Celsius, with endless waves of heat and blowing sand stretching across the horizon. But inside the train, it feels like autumn. The seats can be adjusted, and the windows can even change their tint automatically. Those flashy details you see in the videos. The gold-colored lighters, smart dimming windows, cup holders with ambient lighting. None of them are what truly matters about this railway. In fact, you could say these things are there to distract you. The things that truly matter are the things those videos never show you. It is a ledger, a massive financial ledger involving tens of billions of dollars in decisions that will last for decades. There is no word called friendship written in this book. There is no space for emotional storytelling only. Profit margins, depreciation rates, tax bases, cash flow, and a much bigger question, can a country survive without depending on oil? So how exactly did this desert railway balance the numbers? And why did China succeed at something Europe struggled with for half a century? Saudi Arabia is roughly the size of Western Europe. But until 2018, the total length of railway lines that could operate normally in the entire country was less than 1,000 kilometers. What does 1,000 kilometers actually mean? China's high-speed rail network reached around 46,000 kilometers of operating lines by 2025. For Saudi Arabia, one of the richest oil countries on earth, that number was not even a fraction of China's network. Why? The first reason is simple. It is just too hot. In the middle of a Saudi summer day, surface temperatures can climb above 58 degrees Celsius. Rail tracks are made of metal, and metal expands when heated. If gaps are left between rail sections, thermal expansion can squeeze those gaps shut. Then the tracks start bending and twisting like a giant metal worm. This is called track buckling. And when a train hits that kind of deformation, the result can be catastrophic. So what if you remove those gaps completely? That was exactly what European engineers tried when building railways in Saudi Arabia. They welded the rails together into continuous tracks with no gaps. And what happened? Those hundreds of kilometers of seamless steel rails built up enormous internal stress under the desert heat. The tracks became like a stretched bowstring, constantly under tension and ready to snap out of shape. That is why many older Saudi railway lines had to slow down dramatically during summer or even suspend operations. Some trains were forced to crawl at speeds of around 25 kilometers per hour. At that point, even an electric scooter could beat them. The second problem, sand. The second problem is sand. You might think, it is just sand. How bad can it really be? Under a microscope, desert sand is not some harmless pile of dust. It is made up of sharp-edged silica crystals with extremely high hardness. Once a train starts moving, even at only a few dozen kilometers per hour, the airflow can pull these tiny particles into mechanical gaps and internal components. Once those sand particles mix into the lubricant, the bearings basically turn into grinding machines. They start destroying themselves from the inside. Many precision locomotives built in Europe required major overhauls after only a few months operating in Saudi Arabia. And the cost of one major repair could be enough to buy several brand new trains. Saudi Arabia sits on some of the largest oil reserves on earth. Yet for decades it struggled to build a truly reliable railway. The problem was never money. The problem was technology, and more importantly, even if those railways were forced into operation, the maintenance costs were so high that they made the entire project almost impossible to justify. Before 2020, the average reliability rate of Saudi Arabia's railway system, meaning the percentage of trains that could complete their entire journey normally, was below 65%. In other words, for every 3 trains that left the station, roughly 1 would fail somewhere along the way. This kind of infrastructure investment was nothing more than burning money. And the money being burned was US dollars. So does this mean Europeans simply didn't understand how to build railways in the desert? Of course not. Britain, France, Germany, these are all industrial giants with decades of engineering experience. The real problem was something else. Their business model was never designed around building a railway that Saudi Arabia could maintain independently. Back in the 1980s, a German company built a section of railway in Saudi Arabia. The signaling system alone cost hundreds of millions of German marks. But after the railway started operating, every spare part had to be purchased directly from the original German manufacturer. Even a single screw could require a 3-month ocean shipment. Maintenance engineers had to fly in from Frankfurt. Their consulting fees were charged by the hour. Even their 5-star hotel stays became part of the project cost. What do you call this? It is the razor blade business model. Sell the razor cheaply, then make the real money by charging a fortune for the blades. For half a century, many European infrastructure giants followed the same strategy in the Middle East. Win the contract with an attractive construction price, then recover the profits slowly over decades through spare parts, technology upgrades, and manufacturer-controlled maintenance. And when Saudi Arabia finally calculated the full cost, they discovered something shocking. For every $1 spent building the railway, they might spend $10 keeping it running. But there was an even more powerful weapon: standards. For decades, railway signaling systems around the world were heavily dominated by Europe's ETCS standard. Once a country adopted that system, almost everything related to signaling, hardware, software upgrades, and technical support had to come from those same European suppliers. This is called standards lock-in, or, in economic terms, path dependency. Put simply, once you get on my ship, don't expect to easily get off. So when engineers from China Railway Construction Corporation and CRRC walked into the Saudi Railway Authority with their proposal, many European consultants did not welcome them. They laughed. Their questions were, does your Chinese technology have European certification? Is your system compatible with our signaling standards? The message behind those questions was clear. Kid, we have been playing this game for decades. You want a seat at this table. First, learn the rules. So how did the Chinese team respond? They didn't slam the table. They didn't make political speeches. They did one simple thing. They opened the ledger. The first page of the ledger. Temperature. European standards argued that continuous welded rails would build up too much stress under extreme heat, so their solution was to slow trains down or suspend operations. That was passive adaptation. China took a different approach. If the stress cannot be eliminated, then strengthen the material enough to withstand it. They worked together with Ansteel Group and modified the steel formula by adding tiny amounts of chromium, nickel, and vanadium. These elements rearrange themselves within the steel's crystal structure, changing how the material behaves under extreme heat and reducing high-temperature creep. Put simply, at the same temperature above 50 degrees Celsius, your steel starts to weaken. Ours stays strong. This material formula reduced the thermal expansion coefficient of the rails by nearly an order of magnitude. Then, combined with China Railway's integrated ballastless track slabs and high-strength fastening systems, the heavy-duty clamps that locked the rails firmly in place, hundreds of tons of thermal stress were physically contained and stabilized on the desert ground. The result: under the same 58-degree desert midday heat, European railway systems struggled, but the Chinese-built railway kept running. Page 2 of the ledger: sand. European locomotives rely heavily on air convection for cooling. That works perfectly well in Europe, but in Saudi Arabia, it basically turns the train into a giant vacuum cleaner. The Chinese team's idea was simple. If fine desert sand can get everywhere, then don't give it a chance to get inside. They designed a 3-layer sealing system underneath the train. The first layer uses aerodynamic blades. By using the airflow generated during high-speed operation, larger sand particles are pushed away before they can enter. The second layer uses high-precision metal-sintered filters to block microscopic sand particles. The third layer maintains a slightly positive pressure environment inside the core electrical compartments. In simple terms, the pressure inside the compartment is slightly higher than outside. Outside air cannot easily enter, but internal air can still escape. After real-world testing, the results were impressive. Following a Category 12 sandstorm, the amount of remaining dust inside the electrical compartment was less than 0.01 grams per cubic meter. What does that mean? There was less dust inside than what you would find sitting on a bookshelf that hasn't been cleaned for a month. Page 3 of the Ledger Water in Saudi Arabia. Fresh water can sometimes be more expensive than oil. Desalinating seawater costs roughly $1 to $2 per ton. A large construction site can consume thousands of tons of water every day. And the water bill alone can eat directly into project profits. The Chinese team built a 3-stage reverse osmosis wastewater recycling system. It allowed more than 85% of construction wastewater to be reused. They did not need to take a single extra drop of water from Saudi Arabia, and they added 0 additional water costs to the project. What do you call this? This is fighting for every possible marginal cost advantage. By optimizing every single detail, one cost after another, China's final proposal came in nearly 20% cheaper than its European competitors, and the promised availability rate, meaning how many days per year the railway could operate normally, was set above 97%. Saudi decision. Makers were not naive. They picked up their calculators and ran the numbers, and they discovered something. The total life cycle cost of the Chinese solution was only about 60% of the European alternative. Once the numbers reached that point, who would still argue only about certification standards? If it works, it works. And when it comes to infrastructure, cost efficiency speaks louder than anything else. Signaling systems, the real battle for future influence. Chinese designers took into account that Saudi passengers are generally taller and larger in body size, so they increased the seat spacing from the European standard of 1 meter to 1.2 meters. They also considered that many Saudi passengers enjoy drinking black tea, so they made the cup holders deeper. They even created dedicated prayer areas, allowing passengers to perform religious prayers during the journey. These details were presented as examples of human-centered design and cultural respect. Sounds touching, right? But here is the reality. These were strategic moves. They were not simply emotional gestures. The real situation was this. If the Chinese team wanted to challenge Europe's dominance in railway standards, they had to start with the smallest details. They needed Saudi passengers to physically feel that Chinese trains were more comfortable. They needed to create a kind of muscle memories. Chinese trains feel better. This is called user habit formation. But the real battlefield was never the seats. It was inside Saudi Arabia's railway control rooms. Signaling systems, the real battle for future influence. Europe's ETCS Level 2 signaling system relies on large numbers of trackside radio block centers and GSM-R communication base stations. This works well across Europe's populated plains. But in the Saudi desert, hundreds of kilometers can pass without a single settlement or power grid. So the question was, how do you power all this equipment? Building a dedicated high-voltage power line would require hundreds of kilometers of cables, plus substations and maintenance infrastructure that would create another massive bill large enough to give any finance minister sleepless nights. The solution proposed by engineers from China Railway Signal and Communication Corporation was distributed off-grid solar-powered signaling stations along the 700 kilometer railway route They deployed more than 300 independently operating miniature signaling towers. Each tower came with monocrystalline solar panels and energy storage batteries. No connection to the national grid was needed. Each station generated its own electricity and used it locally. At night, the batteries kept the system alive. During cloudy weather, redundant designs provided backup power. European supervisors raised a concern. When a sandstorm hits the desert, won't the solar panels be completely covered with dust? How can they keep generating electricity? The Chinese team did not argue. They simply brought the same type of solar panels into a national wind tunnel laboratory. They blasted them with sand, filled airflow at 40 meters per second for 72 consecutive hours. Then they presented the results. Power generation efficiency dropped by less than 2%. The self-cleaning design worked. The data was right there. The numbers spoke for themselves. The ETCS competition, whoever defines the rules controls the future. After European engineers tested the strength, latency, and interference resistance of the Chinese signaling system, they discovered a fact they did not want to face. The Chinese developed system exceeded the performance indicators of Europe's ETCS Level 2. Pay attention. It was not equal. It was better. Signal strength was 10% higher. Latency was 15% lower. And energy consumption was only 1/3 of the European solution. What does this mean? It means Saudi Arabia's railway authority faced a choice. Continue using European standards, and they would have to pay enormous additional infrastructure costs to adapt them to the desert environment, or adopt the Chinese system, save money, and get better performance at the same time. This is the transfer of power through standards. Once Saudi Arabia accepts this solar-powered distributed signaling standard, when the future Gulf Cooperation Council cross-border railway network expands, future contracts, technology upgrades, and decades of maintenance agreements will likely follow the same Chinese standards. Think about it. If all 6 Gulf countries adopt the same railway standards, the company and country that created those standards effectively gain influence over the region's logistics infrastructure. This is not about selling a few trains. This is about controlling the rules that shape infrastructure itself. So what is the real economic logic? If you read many Chinese reports about Saudi Arabia's high-speed railway, you will often see the same story repeated. The story goes like this. After the high-speed railway opened, Saudi date traders could use high-speed train cargo compartments to transport dates from Riyadh to Jeddah port. Loss rates supposedly dropped from 15 to 3%, and their profits increased dramatically. It sounds like a beautiful story, doesn't it? But anyone who has actually worked in railway operations would probably laugh when they hear this. Why? Because high-speed trains are designed around extremely strict engineering requirements. Their axle loads, track geometry standards, and power supply systems are all highly precise and extremely expensive. Using this kind of premium passenger infrastructure to transport dates and honey simply cannot make economic sense. The transportation cost per ton-kilometer would be far higher than what the cargo could realistically pay. It is actually a very simple calculation. How much can 1 kilogram of dates sell for? And how much does 1 ton of dates cost in terms of occupying space on a high-speed passenger train? Once you run the numbers, you quickly realize this so-called date transportation story is mostly a public relations narrative. So what is the real economic logic? The real answer is 2 words: commuting, or more broadly, building an integrated urban economy. Riyadh is Saudi Arabia's political and financial center. Jeddah is its largest commercial port and one of its most important economic hubs. The 2 cities are nearly 1,000 kilometers apart in a straight line. In the past, driving from Riyadh to Jeddah took more than 5 hours. Flying only took about an hour. But domestic flights in Saudi Arabia were not cheap. And once you added airport security, waiting time, boarding, and baggage collection, half a day could disappear. What happens when this kind of geographical barrier exists? Workers do not move easily. Capital does not move easily. Business opportunities do not move easily. Someone living in the capital who wants to find work in the port city faces huge relocation costs. A company in Jeddah wanting to open a branch in Riyadh faces expensive and exhausting business travel. Two major metropolitan areas were effectively separated into two isolated economic islands by physical distance. This separation prevented Saudi Arabia's service sector, financial industry, and technology sector from achieving true economies of scale. What high-speed rail really changed was the relationship between cities after the Chinese-built high-speed railway began operating. Travel time between the two cities dropped from more than 5 hours to less than 2. Two major metropolitan areas were effectively stitched together into one economic and social circle. You could hold a meeting in Riyadh in the morning, have lunch in Jeddah at noon, meet a client in the afternoon, and still catch the last train home. Something like this would have been unimaginable before. Let's do the bigger economic calculation. Now let's calculate the bigger picture. Within 1 year after the high-speed railway opened, land prices along the previously empty corridor between Riyadh and Jeddah increased by more than 30%. More than 200 cross-border e-commerce companies and logistics technology firms established operations around the Riyadh station area. Saudi Arabia also gained tens of thousands of new non-oil jobs, jobs that do not depend on petroleum revenue. The VAT, income taxes, and commercial rents generated by these positions continued flowing into government accounts. The real logic behind the ledger. So what is the underlying logic behind this investment? First, land value appreciation. Better transportation makes previously worthless land valuable. Second, factor mobility. When people and money can move faster, transactions increase and the tax base expands. Third, economic transformation. A country can create GDP and employment without relying only on selling oil. Executives at Saudi Arabia's Public Investment Fund, PIF, ran the numbers and discovered something important. Even if the railway itself did not generate large operating profits, as long as it could drive land appreciation and increase tax revenue along the corridor, the investment could still pay for itself. This is what a real ledger looks like. Not some story about reducing date losses. That is just a small performance. This is about the survival probability of an entire economic structure. After this railway entered operation, Saudi Arabia awarded both the operation contracts and maintenance contracts to Chinese companies. But that was only the beginning. What happened afterward created the real chain reaction. From 2024 to 2025, delegations from the United Arab Emirates visited Saudi Arabia to study the railway. Then Qatar came, then Egypt, then Kuwait. And they all asked almost the same questions. Can this Chinese railway standard be replicated in our countries? How long would construction take? How much could the full life cycle costs be controlled? The UAE has already signed agreements with China regarding high-speed rail connections between Abu Dhabi and Dubai. Egypt is also discussing desert railway projects connecting Cairo with its new administrative capital across the Middle East and North Africa. Thousands of kilometers of planned railway lines are gradually moving closer toward Chinese standards. This is no longer about one railway. It is about an entire network. When all railways in a region adopt the same technical standards, the ability to control scheduling, maintenance, and future upgrades naturally falls into the hands of whoever created those standards. And Europe is watching something it spent half a century building in the Middle East slowly being challenged. The railway standards fortress they created is being broken through by a Chinese approach that is cheaper, more durable, and more adaptable to local conditions. the deeper exchange, energy and finance. But the deeper exchange is happening in energy and finance. In recent years, more and more discussions have focused on whether China-Saudi oil trade could increasingly involve yuan settlement. In 2023, the Export-Import Bank of China and Saudi National Bank signed a local currency cooperation agreement. And in 2024, Saudi Arabia's finance minister publicly stated at the World Economic Forum in Davos that the country was open to the possibility of using the Chinese yuan for oil settlements. If you look at these events separately, they may seem unrelated, but connect the dots: railway standards expansion, yuan-based energy settlement, cooperation in new energy supply chains, and a much clearer pattern begins to appear. China helps Saudi Arabia address one of its biggest challenges: economic transformation beyond oil. In return, Saudi Arabia creates more room for cooperation with China in energy security and financial settlement. This is the underlying logic of transactions between major powers. It is not about hosting a dinner. It is not about emotional friendship. It is about exchanging interests. It is a set of numbers drawn by a steel rail across the Rub al Khali Desert. Those numbers may eventually appear on the screens of the Shanghai crude oil futures market, on the currency settlement documents of small exporters in Yiwu, and even in the bus fares of the city where you live, because more stable energy prices help control transportation costs. Conclusion: the most impressive things are never what the camera shows. Today, in 2026, if you travel to Saudi Arabia and open your phone map to search for the Haramain high-speed railway, you will see the railway stretching from Mecca all the way to Medina, crossing the entire Hejaz region. Zoom in, and you will see high-speed trains moving steadily through the desert. But the things the camera cannot capture are the things that truly deserve attention. It is the specialized steel developed by material scientists at Steel Laboratories after thousands of formula adjustments. It is the engineers at China Railway signal and communication testing solar panels inside a wind tunnel while blasting them with sand for 72 hours. It is the nights when China Railway project managers sat across from Saudi finance officials, going through a budget book thicker than a dictionary, page by page, line by line. None of these things are romantic. They are boring. They are repetitive. They are the kind of difficult, dirty work where designs are constantly challenged, rejected, and rebuilt from scratch. But the outcome of competition between major powers has always been built little by little through this kind of difficult work. Europe spent decades building desert railways, billions were spent, yet what remained was a system that struggled to operate efficiently, along with a business model heavily dependent on selling spare parts and long-term services. When China arrived, there were no grand speeches. They simply strengthened the materials, improved the sealing systems, created closed, loop water recycling, and powered signaling systems with solar energy. Then they calculated the numbers: 40% cheaper, twice as reliable. The rule of this world is actually quite simple. Whoever can solve the hardest problems and make the numbers work gets the ticket to the next round. And in the Saudi desert, China got that ticket. As for what this ticket will eventually be worth, how quickly the yuan can expand its role in the Middle East, whether Chinese manufacturing standards can become the mainstream of future global infrastructure, and whether the next generation will gain new career, opportunities because of this system, those answers are still being written in the ledger. The account has not been fully settled yet. But at least the ledger is now in Chinese hands, and for now, that is enough.